Okay, so I think we should start. So, hello everyone. I am Divyanshu Divakar, and I am today's host for today's session. Okay. So first, let me give you all a brief introduction about the null. Null is basically an open community for security. You can come here and learn about the security stuffs and also the coding stuffs in this community. It is free for all. Okay. So who we are? We are one of the most active community in security with 15 chapters running in India and across the globe, like Null Dubai and Null Amsterdam. Uh, who are the members of Null? Basically, members of Null include security professionals, penetration testers, security managers, developers, and if you are a student, then you also can come. But you have, if you have if you are a cybersecurity enthusiast, okay. What do we do? We eat, sleep, hack, and repeat. Uh, and what do we have in Null? We have monthly meetups, Hamla session, Bachao session, and Pulia session. In Hamla session, we focus on the offensive side or the red teaming part. In the Bachao session, we focus on the defensive or blue teaming part. In Pulia session, we bridge the gap between the skills of the members of the Null community. And then we have monthly meetups, which held every month of the year. So we have our Null Bhopal team. We have Shreya Pohekar, Shiraz Ali, Devansh Dubey, Laksh Dubey, and it's me, Divyanshu Divakar. So what you can get from the Null community, you can benefit it for learning purposes. You can increase your network. You can meet with some cool security professional which are already in the security professional. You can get your name out there by giving some session in Null Bhopal. How you can be a part of Null? You can be a part of Null by joining mailing list, attending meetup workshops or virtual meetups. You can register yourself on null.co.in, or you can also become a volunteer of Null community. So I am handing over mic to our speaker, Mr. Swamedeep Basu, who is speaking on Bloodhound and how to build custom cipher queries in it. So Swamedeep, you can take over the mic.
Thank you, Divyansh. So let me share my screen. So the topic of discussion today will be Bloodhound beyond the GUI and building custom cipher queries. First, a little bit introduction about myself. I am a red team enthusiast, upcoming research and development intern at Fire Compass, and I love snooker. So all snooker lovers in the house can give me a cheer. The agenda of today's discussion is broadly divided into four parts. First will be the basics of Bloodhound. We will look at the object representation of computers, users, and OUs and how these are interconnected in an Active Directory database. We'll also talk about the Neo4j, that is the Graph Database Management System, and next we will come over to cipher queries, which are basically the building block of Neo4j. We'll understand cipher queries and we'll also build custom ones as per suited to our needs. And lastly, we will end with the latest research work being done in this area by eminent security researchers like Harmjoy and Captain Jesus. Bloodhound 101 or Introduction to Bloodhound. If we go after the basic terminology, we have three main features in Bloodhound, that is a node, an edge, and a path. Now, what exactly is a node? Any object on a graph will be a node. It can be a computer, it can be a user, it can be an OU. Edge, a relationship between the two nodes. Whenever two nodes are connected by a particular edge, we say that these two are related to each other by some factor. Then we have a path, that is nodes connected by edges. So the entire connection between two nodes will be a path. Types of nodes. Initially, when partial version 1 was released, there were only three types of node present: user, group, and computer. But however, with successive evaluations of the different versions of partial, there were more and more complications arise, and as and when different types of nodes were introduced, now we have support for GPO as well as OU. And with the latest Bloodhound version, as of a few days back, it includes Azure nodes and edges as well. That means that it will have Azure Active Directory support in Bloodhound as well. Again, the default edges that were present in the starting version of Bloodhound were member of admin 2, has session, and trusted by. So they again, in the next subsequent version, they introduced ACL or access control list edges, and these edges include all extended rights, add member, generic all, generic write, force change password, read lapse password, write deckel, write owner, and owns. We'll go into detail of each and every edges later in a demo. And GPOs, that is group policy objects, and OUs, that is object units, will have different edges like contains and GP link. There are some special edges that is obviously dependent upon a special type of attack, is known as delegation attacks. These are impersonation attacks. That means you can impersonate a user on behalf of another user. These include can RDP, execute decom, allowed to delegate, allowed to act, and add allowed to act. Now, we'll talk about Sharphound. That is, before we move into Bloodhound, there is something known as ingester. Now, ingester, what it does is that it will query the Active Directory database of all the objects, say computers, users, OUs, and it will store all the information so that it can build a graph later and then present it in a human readable form. So, Sharphound is a C hash rewrite of the Bloodhound ingester. It comes in two different forms. We have a command line format, that is a .exe, as well as a PowerShell script that contains the same assembly, although it is a bit obfuscated in nature to avoid AV detection as the exe. As we run Sharphound, the Sharphound will collect all information about the Active Directory as from the perspective of an authenticated user and its users, computers, and groups with the help of LDAP queries and simple Win32 API calls. Now it takes all this information and it builds up a JSON file. It builds up JSON files and then puts them into a zip. Now this JSON file can be used anywhere in the world when a Bloodhound instance is running. So that means that it is portable across systems. We have a particular JSON file. We can use it anywhere in the world in order to map your network and find attack vectors and find larger attack surfaces. So now it's the time for a Bloodhound demo. So this is the graphical version of Bloodhound, and this is an example database that I have. I have a lab set up in my local computer. So, or else there are two ways in order to get a database. You can either set up a lab yourself, Active Directory lab, or you can use a particular tool. I'll be showing the next slide, wherein you can generate some example data in order to work on it. We'll start with this part first. We have a start node and we have a target node. So say we want to find a particular node, say the services admin. So I will type here services admin and will provide us this node. Upon clicking, it will give us the information about the node. So we see that service admin has 0 session, sibling objects in the same OU or sibling objects in the same organizational unit are 23. If we click on this, it will give us all the sibling objects of the it will give us all the sibling objects of services admin. Now, from services admin, we see that reachable high value targets are targets that are sensitive in nature and have possess sensitive information. We are 9. So we can click on this and it will show the path from services admin to these reachable high value addresses. So if we look at one of these paths, we see that the services admin is a member of domain admins, and domain admins have ACLs over these. So domain admin owns administrator, that is the 500 read account. It owns account operators. It has a generic all permission. That means it can read, write, or even modify the group policy creator owner object. It has a generic right, and like this, we have all extended rights on the domain itself. So one of the most interesting features of PowerShell is that it not only shows us the corresponding ACL that is present between the two nodes, it will also help us using the help command in order to how to exploit that ACL and use it to our advantage. So we see that the user services admin is a member of the group domain admins, and we have a particular information about what exactly means member of. In the next part, we have abuse info. So abuse info, in this case, since it's a member of, we can directly execute commands. So there is not exactly an abuse, but however, in other cases, we can have abuse. So let's take an example. Let's find shortest paths to domain admins. So let's take allowed to delegate ACL. If we see allowed to delegate ACL, we have a DB service, which is a node, and it has an allowed to delegate permission on UFC DC1. Now, if we click on the help, it will show that the user DB service is allowed to delegate. That is, it has a constrained delegation privilege to the computer ufcdc1.funcorp.local, and now it gives us information about the constraint delegation. And the constraint delegation means is that this user is allowed to run or allowed to authenticate to other servers impersonating this computer. Abuse info. So it will give us some commandlets as well as the tools that we need in order to abuse this ACL. So it tells us that we can use the S4U extension of Rubius in order to exploit this particular ACL. It even gives us OPSEC considerations because obviously we need to think from the blue team side as well. So as mentioned in the abuse info, we see it is in order to currently abuse this primitive, the Rubius C hash assembly has to be executed in the system. And since C hash assembly code is being executed, we need a particular CM or a particular SOC in order to defend against this attack. It gives us basically the artifacts that is left over when this attack has been occurred already. It will give us references. We can find out external references in order to help perform the attack better. And so the query, so this part gives us queries. So these are pre-built analytical queries that are present inside Bloodhound by default. And later on, we will learn how we can build our own queries and add them to the custom queries section. So let's try shortest path from owned principles. So we have jump SRV admin. So jump SRV admin, suppose in a particular red teaming attack, you have already owned a particular user. That is, you have owned this particular user or system, say jump SRV. So you can mark it as owned. Now I had previously marked as owned, I marked it unknown now. So I'll mark this computer as known, and since I mark this computer as own, I can see that this UFC jump SRV has an admin to, that is jump SRV admin is an admin to UFC jump SRV. So we can possibly extract the credentials of jump SRV from LSAS. Let's try out some other queries as well. Yeah. So let's see this one. We have an account operators OU. So this account operators group has a generic all permission on DB service. So if we have some user present in the account operators group, we can use this generic all permission and change the password of the DB service user, and then using the modified password, since you already know the password, you can log in as the DB service user and then continue your attack. So I've already discussed this allow to delegate part. And next, suppose from this account operators, we need to reach domain admin. So we have then allowed to delegate will exploit this ACL, will get access to UFC DC1, in which an administrator, that is the RID 500, that is the RID 500 administrator has a session. Since it has a session, it is highly probable that there the credentials will be stored or can be extracted from the LSAS. And since we have the credentials of administrator now, we are already a domain admin, since the local admin administrator is a part of domain admins. There are various more uses of partial, like suppose we have a user, say DB service, and from DB service we want to find a path to the domain admin. So we can click on this. It will like give us a pathfinding algorithm. It is based on distra in the background. So DB service, to say we want to find to domain admins. Okay, so we see that DB service user has allowed to delegate ACL to EFCDC1, which has a session, the administrator, which is the member of domain admin. If you want to see how to exploit this one, so since it has a session on the computer, abuse info, whenever a user has a session on a computer, we can find credentials for that user via credential dumping or token impersonation. And accordingly, we have OPSEC considerations too. That is a particular high-end EDR product can detect injection attempt into LSAS and alert a SOC employee. These are mostly the functionalities of Bloodhound. And we can export the graph. Suppose we have a particular graph, we need to export it for say bookkeeping purposes. We can export the graph, we can import databases, and it gives this database info gives us a overview of the database. That's the number of users, computers, groups and sessions, relationships and ACLs. And finally, we'll come over to this part in a very subsequent section. We have a raw query part wherein we can execute our own custom queries. Let me shift over to the slides now. So as I was saying, that suppose you don't have an Active Directory lab set up at home, because there are some hardware configuration that need to take place. So where can we find a data set for practice? We can use Bad Blood, that is a GitHub repository by David Pro. What he has done is that he has basically made a partial script that will help you to fill a Microsoft Active Directory domain with a structure and thousands of objects like user objects, computer objects, OUs, and then link them with particular paths, edges. And the output of this tool will be a domain similar to a domain in the real world. So we need to just set up a domain controller and execute this tool with the privileges of an enterprise admin. Coming over to the second part of our session, that is Neo4j database query language. Neo4j is basically a graph database management system. We have heard of database management systems like SQL. We have heard of MongoDB databases. Neo4j is basically based on graphs. Now, what is exactly a graph database? A graph database is a database that assigns equal permissions, that will that finds equal importance in the data as well as the relationship between the data. In case of databases like SQL, we see that query is being done in a particular query time. But however, since Neo4j holds relationship between the data as well, query is done much faster. So what is Cypher? So Cypher is basically the underlying language that builds on Neo4j. Cypher is Neo4j's graph query language that helps users to store and retrieve data from the graph database. Cypher, the main aim of Cypher is to make querying graph easier to learn, understand, and use for everyone, and not only security professionals, but also it will help us to incorporate the power and functionality of standard data access languages. The basic schema of representation of a cipher goes as node to edge to node, and a node is generally represented in in circular braces and an edge in square braces. This is a basic schematic representation of a cipher. So for an example, we can say that Bob likes Alice. So there is a node Bob and there is a node Alice, and there is an edge between the two that denotes likes. So we can ask like who likes Alice without knowing Bob in from the beginning, or we can go the reverse way around. We can say like who does Bob like, and finally we can also go and ask that what is the relationship between Bob and Alice. Now there might be more than one relationship between Bob and Alice, so in that case the query should return all those that are applicable. So any questions still here?
Yeah, hi Swamidi. Can you explain Sharphound a little bit more?
Yeah, so I'll move over to the slide again. So a sharp hound is basically, it comes in two features. That is, we have an exe that can be run on a Windows machine that should be joined to the domain itself. And so that it needs to be joined to the domain so that it can query and extract data out of the domain in form of LDAP search queries and even Win32 API calls. And we have a PowerShell script. So exe is there in order in the case that there are some systems where the PowerShell execution is disabled by GPUs and all. So it will help you. This Bloodhound ingester or Sharphound is written in C hash and will help you to extract the entire data out from the database, and then it will build JSON files corresponding to users, computers, ACLs and all, and this JSON file needs to be extracted out from the Windows machine and then put into a running instance of Bloodhound so that it can give you a interactive graph that is easy to read or easy to visualize.
Okay, okay,
So
thanks.
did I
That
answer
works
your
for
question?
me. Yeah.
Sure, sure. So I'll move over to the next part. We will learn Cypher. We all know about SQL queries, right? And let's learn Cypher by comparing it to SQL queries. So we know that basic SQL query goes like select from, and in case of Cypher it will be match pattern, return it. So if we say in terms of SQL, select this information from the table and give it back, and in corresponding Cypher terms, return me any data that will match the given pattern. Now, in case of SQL, we need to join data from two or more tables. So we say select from and join. Now, in Cypher, we do not have a join keyword, but instead we will use a much more complex pattern in front of the match statement, so it fits our query, right? And we'll return it again. In Cypher, we do not have tables or joins, instead of nodes connected by relationships. In both SQL as well as Cypher query language, we will use the where clause to filter information. So select from where in case of SQL, in case of Cypher, we will say match pattern where condition pattern. So this where clause helps us to add much more filters to already what is being filtered from the match pattern query. So match pattern where condition slash pattern and return it. In Cypher, we do not have tables or joins, instead nodes connected by relationships. And a basic node syntax goes like this. This nothing in between, braces with nothing in between, represents all type of nodes. And if we have an a in between the braces, it says all types of nodes via a variable a. Now this variable a must be of a particular type predefined earlier. And in between the braces, we have a colon and a label. So all nodes of the specific type via a label. If we mostly we will use this version, c colon city, it means that all nodes of type city via c. So the pattern goes something like this: match a, return a. uh, yeah, so match c colon city, return c. This query will give us all the cities and will return it via the variable c. We'll come over from the node syntax. We'll now come over to the relationship syntax. A pointed arrow represents a relationship direction, whereas a colon rel underscore type means the type of the specific relationship. So adding both of them together, this the third one here represents the directed relationship of type from. That is, it is directed from the left hand side to the right hand side, and the type of the relationship is of the type from. So as an example, we say match p colon person directory relationship from to C colon city. So the output of this particular match query will be all relationships from person to city. Now we have included a filter where p dot name equals Rahul. So we will match all persons whose name is Rahul to the corresponding city, and we have returned p comma c. So the output will be list of Rahuls from all cities in the database because we have not filtered on the c value. As a new example, match n comma user n colon user comma m colon group. So we see that we are already assigning n and m labels user and group. We need to match p equals n from r colon member of star 123 to m. Now this exact meaning of this match query goes something like this. So we'll find n is a user, m is a group. So we are finding relationships from user to group. And we are defining the relationship R as the user must be a member of the group. So the user, if we omit the one dot three part as of now, we see that user must be a member of the group. Now this is basically a length modifier. We are adding a length modifier to the relationship that limits the search between 1 and 3 links. That means the user must be a direct member of the group, or a user can be a linked member of the group up to 3 hops. So let's try and run this query in the Active Directory database. Okay, yeah, let me share my screen. So we'll use this query. We'll use it here as well as in the Neo4j database. Yeah, so this says that a graph will take long time to render because there are, we can see that there are 1990 users and 53 groups. And since we are running this query, which says that we need to find users that are part of groups up to 3 hops, that means it will give us an enormous amount of data. So we'll leave it for now. We'll use another query as an example. Yeah, just a second, I think. Yeah, so yeah. Next, the next Cypher example will be match n colon user m colon group, and in this time we will add a particular filter to the group itself, say domain names at the rate us.funcorp.local. So this is basically the query that we run when we say we need to find the shortest path to domain admin. So we will have the group filtered by domain admins at the rate us.funcorp.local and n as a user group. So we need to find the shortest path. Now shortest path is an inbuilt function inside the Neo4j database. Shortest path from n to m with more than one hops. Now the actual meaning of star one dot dot means that we can have infinite amount of hops until we find the particular group. Return p. So we will still use labels to specify the nodes. We can also add another degree of specificity to the group by saying that we will restrict the group nodes returned only to domain admins at the rate us.funcorp.local by specifying, sorry, the name parameter. Now because we did not return any relationship level. We did not filter on the relationship level. So the query will be possible for any relationship we can find. Next, find all edges any owned user has on a computer. We'll find all edges that any owned user has on a particular computer. Let's try and run this query on the Bloodhound. So yeah, cancel. We'll cancel the previous one. Let's try. So we see that we are trying to find edges from owned principles to any other computer, as well as along the shortest path. So I will explain the query in a little bit. Let's first find that we see that PS student 132 at the rate us.funcode.local is an owned node, and we are trying to find the edge. We see that we have a can RDP edge into PA user 132. So using Bloodhound inbuilt queries, we cannot find this particular information. Only if we have the knowledge to find custom, we need the knowledge to edit custom queries or build custom queries, we can find such crucial data inside such a huge database. I'll switch over to the slides again. So let me explain the query now. Match P equals shortest path. So you are using the inbuilt shortest path function inside the Neo4j database. M user, that is M is defined as a labeled as a user, and B is labeled as a computer, and R is a relationship. Now we have not set any filter on R, so it will have generically any relationship. Where M dot owned, that means M must be owned, this must be an owned principal, and will return P, all such edges. Find all computers with unconstrained delegation enabled. So we'll have a match query. C computer, that is computer C is labeled as a computer node. Unconstrained delegation colon true. So unconstrained delegation on the particular computer must be enabled and will return all C. So let us find this on the Bloodhound. I'll quickly copy this query and I'll run it on. I think my Bloodhound is visible. Yeah. So I'll run it there. So you can see that we are finding all computers where unconstrained delegation is enabled. We have two computers here. We have UFC webprod us.funcorp.local, and we have UFC dc1.funcorp.local. So these computers have unconstrained delegation enabled, and hence these respond to the Cypher query. Again, I'll switch over to the slides. Yeah. So next, return username and number of computers that username is admin for, either explicitly or via group membership for top n users. In this case, we have said n must be 5. So what is asking, the Cypher is asking for to return username and number of computers. So we need to find the return statement, return n comma c, where n should be the username and c should be the number of computers that must be unique. And these, what is the relationship between these? The username is admin for either explicitly group membership or via group membership. That means the particular username must be an admin on that computer, either explicitly, that is directly, or via group membership. So we'll use the match query again. We'll give u with a label of user, and this is the particular query that matches from user to a computer with the relationship that says that the user must be a member of, or it must be a directly admin to the computer. So it must be a member of a group that is admin on the computer, or it must be a direct admin on the computer. And again, we have used the length modifier up to infinite hops that will help us to find the computer at the very end of the hop. Now we need to return not the user node but the name of the user. So we'll use with u.name as n. So n now stores the name of the user, and c, that is previously we stored the label computer, will use distinct c. Now after finding all the edges or all the paths from a particular user to a computer, it might happen that there are some duplicate computers. So we'll first apply the distinct operation, that is the inbuilt function of Neo4j itself. On C, it will give us all the distinct computers, and then we'll apply a count operation, which will give us the count of those computers, and we'll store them in the variable C and return n comma C. We'll return n comma C, that is the username and the count, ordered by CDESC, that is ordered by the decreasing order of the number of computers, limit 5 as in 5 users. Let's now try and run this in Bloodhound. I'll share the Bloodhound screen. We'll quickly copy the query itself. Yeah. I think I'm visible there. So I will use it in the Neo4j database, because in case of Bloodhound, if I try and run this in Bloodhound, the catch is that it cannot return any data from the query, because we are returning integers and strings and not nodes that Bloodhound can graph. So we'll use it in the Neo4j database. Just restart the browser. So we can see that N here and C here, we can see that the 500 root administrator is an admin on 3 computers. The services admin is also an admin on 3 computers. And we have correspondingly passed in 137, 134, and 138 with the number of computers it is admin on in the decreasing version of C, since we are using order by CDSC and limited up to 5. So we see that this works. Let's switch over to the slides again. Next, find users with passwords last set within 90 days. So we'll have a U as an user with a label user, and where u.pw last set. Now this user has a user u has a particular property password last set, and we'll set that we'll find all users with password last set is less than a particular value. Let's see what the particular value will be. We'll try the date time function, which will return us the current date and time. We'll convert it into epoch seconds. We'll convert it into epoch seconds, and we'll subtract it from 86,400 into 90. Now 86,400 is basically the number of seconds in a day, and by multiplying into 90, we say the number of seconds in the last 90 days. And if we subtract the current date and time from the number of seconds in the last 90 days, it should it should not be between -1 to 0. If it is between -1 to 0, that means the password last set of the user is not within 90 days. So we'll use this query, that the current time into epoch seconds minus 90 into 86,400, and not password u dot password last set in -1 comma 0. If these two conditions satisfy altogether, then we'll return such a user u. Let's now try this on a database itself. I'll share my screen. I'll quickly copy the query. So this is the raw query. Yeah, and return me. So again, we see that this will take some time to render. Okay, let's try it out here. So because most users have password last set in 90 days, so it will return almost all of them users. So the Bloodhound will take some time to render these. And as again, Neo4j will try out the next query using Bloodhound. We'll just stop this one. I'll move over to the slides again. And the resources. So I'll release these links after the talk, and you can find some interesting resources if you want to study more on Bloodhound as well as ciphers. The latest or future work being done on this topic is Cypher Dog. So Cypher Dog is basically the creation. It's open source by SAD processor. Now SAD processor, what he did is that he used PowerShell commandlets to interact with the Bloodhound data via the Neo4j HTTP API. Now, whenever we run a particular query on Bloodhound, it is being queried on the Neo4j database via this Neo4j HTTP API, and then it fetches those results and shows them in a very graphical manner. So a SAT processor, what he did is that he introduced PowerShell commandlets. He wrote them by himself so that he can interact with the data that is present in the Neo4j database. This Cypher dog has the ability to build Cypher queries on its own. So it saves much of the time. You don't need to memorize long and complex Cypher queries, but still then the knowledge of building custom Cypher queries helps a lot in the long run. So for example, if we import the CypherDog PowerShell file and after that you use a particular command shell, say path, user, group, start, domain admins at the rate us.funcode.local, it will show you the exact path from this user star, that means any user, to domain admins. So the final result of the query will be the path from any user to domain admins. So no presentation is complete without a meme, and we see that so this no offense to blue teamers, of course, they are doing a really great job, and really appreciate that they find out artifacts from red teamings. After all, it's a cat and mouse game. So whenever Bloodhound is in action, so blue teamers and red teamers alike, they are benefited. So thank you for having me, and if you have any questions, please feel free to ask.
So we should wait
Uh,
1 or 2 minutes for questions from the viewers. So Swamedeep, it seems like there are no questions in the comments. So thank you very much for the session, for this wonderful, awesome session, and thank you again, and have a nice day.
Thank you.